What's going on, guys? So today I want to talk about polyatomic ions. So polyatomic ions are things that occur in nature all the time. So sort of we treat these things as atoms in and of themselves almost. These things will move around and as a bunch of atoms, rearranging themselves as that same group in various chemical reactions. And we'll see these show up in organic chemistry and inorganic chemistry and analytical chemistry, and they just show up everywhere. And so being able to understand them, being able to understand the structures and being able to recognize them is going to be something that's very useful to us in the future. And we also are going to get introduced to some Lewis structures here as well. So I want to start off by looking at this structure here, and I'm going to go ahead and zoom in on this structure. Okay. And by zooming in on this structure, I'm going to zoom in a little bit more. We notice that we have bromine surrounded by 4 hydrogens, or 4 oxygens, my bad. And if we remember the octet rule, every single atom in this scenario wants to have a full outer layer of electrons, okay? And so these guys can get paired with, so he can get paired with him to fill his pair. This guy can pair up with this guy, and oxygen now has full octet, and so does bromine. These electrons right here are being shared. Okay, these two can be paired. Okay, now this one is where we could pair this one with this one, but we'll pair these two with these two, and we'll see why I'm doing this later. And then these can get paired with these guys. Okay, and so this overall thing now has a leftover electron, this little exposed electron here. If we remember that electrons have negative charge, this polyatomic ion, it's an ion, therefore it has a charge, and that charge comes from this little lone electron here. That ion has a negative charge to it. Okay, and this thing therefore has a -1 charge to it, and this whole thing can be written as BrO4. Okay, this is BrO4, and it has a minus. It has that negative charge on it there. And that's because of this lone electron. Okay? Now I want to come down to this guy here. Now, this is the same situation, but I'm going to say that this oxygen doesn't exist. I want to see what happens if our bromine is only in contact with 3 oxygens, okay? So this guy can get paired with that one. He can get paired with that electron. This electron can get paired with that one. Likewise for those two right there. Those guys can get paired. And again, we have this negative charge here. And this thing can be written as BrO3 because it's only 3 oxygens in this system. And we have that still that negative charge there because of this exposed electron. Okay, it's not paired with anyone. It's not paired with any other electrons. And so these are just 2 examples of polyatomic ions that have a negative charge to them. Okay, -1 charge to them. And these guys here, now I have this list here. These are the names. Okay, what I wrote out here is this is per bromate, this structure right here. So this is BrO4 minus, okay. And then this guy down here, this BrO3 that we practiced on, is bromate. BrO3 minus. Bromite is going to be BrO2 minus, and these all have a -1 charge to them, so we could put a -1 right there as well. And then hyperbromite, you can see a pattern here. We go 4, 3, 2. Hyperbromate is BrO, and just 1 oxygen. It's got that negative charge on it. And we could practice looking at these guys. Okay, and we could practice with these structures, building the structure for each one of these. And similarly, perchlorate is going to be ClO4. So per is ClO4 with that -1, and you can see the pattern. You can see the pattern up until we get to here, and all of a sudden we don't have a per thing here. As you can notice, all of these guys are based off of halogens. Bromine is a halogen, chlorine is a halogen, iodine is a halogen. Okay, so these are some rules for halogens that are involved in polyatomic ions that have a -1 charge to them. Okay. For the nitrate, we follow similar rules. The nitrate is going to be NO3 though, NO3 minus. Notice here where we have the 8, the following 8 suffix here, we typically have a 4, but for nitrate that differs a little bit and we have an NO3 minus. Okay, and then we have an this can be an NO2 minus. So you can see a pattern. Okay, even though 8 up here implied 4 oxygens, 8 more generally just means more oxygens than ite. A comes before I in the alphabet, you can think of it like that, and you have a rough understanding of perhaps how many oxygens exist in the polyatomic ion. Okay, then we have some of these guys here which are a little bit odd ones. So hydroxide is going to be OH with a minus charge on it. Permanganate is going to be, if I remember correctly, I wrote this down, MnO4 minus. So MnO4 minus. Okay. Then we have cyanide is Cn minus. Thiocyanide is SCN minus. And these are all just atoms. Mn is manganese. Okay, C is carbon, N is nitrogen, S is sulfur. All these, you'll eventually memorize these throughout your chemistry class. And then we have acetate, which is C2H3O2 with a minus charge on it. And then we have bicarbonate, which is HCO3 minus. Okay, bicarbonate is very important in blood physiology, and we'll get to that later too. In these courses, I also intend to go over practical examples that you'll find in your standard chemistry, upper level chemistry classes, and your physiology class as well, if physiology is something that you're going to end up taking or are taking. Ions with a -2 charge. So let's take this example now, and this video, this lesson here, might be a little bit longer than some of the other ones because I want to go through all of the polyatomic ions. Okay, so we have so this carbon here, so I accidentally didn't put the electrons in here. I'll make them black. These are the electrons surrounding the carbon. This can pair up with this one, this can pair up, and these can pair up with those guys right there, like that. And what do we have left? We have 2 exposed electrons, so this thing has a -2 charge on it. Okay, and this thing is CO3 minus with that -2 charge on it. Okay, and that's what we call carbonate. So this is carbonate, CO3 minus 2, and phthalate is C8H2O with that -2. Sulfate, again, 8 implies that we have more oxygens. This is SO4 with that 2 minus. This is going to be SO3 with that -2 charge. Okay. Chromate is CrO4 with that -2 on it. And dichromate is Cr2 with 2 chromates in there. O7 -2 charge. Oxalate is C2O4 2 minus, and peroxide, something that you hear probably very frequently in hydrogen peroxide, is O2 with the negative charge in it. And you can practice all of these by constructing these diagrams and seeing how these things are actually structured. Okay? So that is ions with a negative charge and ions with a positive, or with a negative 2 charge on them. Okay, now I want to get into ions with negative 3 charges and ions with negative 1 charges on them. So let's get back here and take a look at this structure. So here we have phosphorus and 4 oxygens surrounding it. Okay, we can pair these guys up, compare this guy up, we can pair this guy up, and we can pair this guy up, these guys up. And now we have 3 lone electrons. That gives us a negative 3 charge on the polyatomic ion. And this thing is phosphate. This is PO4 with a negative 3 on it. And we have some names down here. Phosphate is what we just drew up here. Phosphite, you might guess already, is PO3 with that negative 3 charge. And arsenate is AsO4, the negative 3 charge on it. Okay? Similarly, let's look at this guy now. Now this is going to be an interesting one because we have, this is called ammonium. I think I might have spelled that wrong. That's why I have that red bar down there. This is called ammonium. What's interesting about ammonium is, let's work this one out. So what I'm going to do is I'm going to put an electron here and an electron here. And this guy's going to get kicked out. Okay? So now hydrogen has a full shell on it, but it kicked an electron out to do that. Okay? And then we have these guys pairing up, these guys pairing up, and those guys pairing up. Okay? Now I will be a little better about this here. We have an M. Okay. I have an extra M down there. NH4 positive charge, because getting rid of a negative charge renders us a positive charge, positive 1 charge. Okay, and this is NH4 with that positive charge on it. So those are the polyatomic ions. Those are some common ones that you'll come across, and some of these you're going to have to memorize, and some of these you won't have to memorize. Depends on the teacher you have. But now we have an understanding of how we can construct these polyatomic ions, and so whenever we see one on a piece of paper in a chemical equation, we can understand this is a polyatomic ion. I'm treating this as sort of its own atom in and of itself, and these polyatomic ions aren't going to rearrange their constituents within a chemical reaction. Sometimes they will, but in general chemistry, oftentimes they won't. Okay? And so I hope you get a lot out of this. I hope you enjoy the way I teach. If you enjoy the way I teach, please hit that subscribe button, and if you're interested in private tutoring, please visit my website at tristancarmacy.com, and I would be more than happy to be a tutor for you. Like always, I'll see you in the next one, and have a good rest of your day.